So on this slide, we have two different titration curves. There's the red one and the orange one. One is strong, one is weak. Which one is the orange one, the strong or the weak? Why is it strong? Lower initial pH. That's the difference between the two. Okay, so let's start moving over. Right at this 20 mil mark, I've got 40 milliliters of 0.1 molar for both. At this 20 mil mark, what's unique about the 20 mil mark for a weak acid? What's pH equal? pKa. Now, it's not always 20 milliliters. It's halfway to the equivalence volume, which in this case happens to be 20 milliliters. Let me prove to you that that does not work for the strong acid, sorry. I have 20 milliliters of HCl times 0.1 over 60 milliliters total is 0.33. I have 40 milliliters. Nope, that's backwards. 20 milliliters of NaOH. 40 milliliters of HCl. All right. So what I did here, and you do not need to copy this down, was I diluted and neutralized, and at half the equivalence volume for a weak acid, I would have ended up with 0.0. These are all O's. I would have ended up with 0.033 molar weak acid and 0.033 molar conjugate base. Those end up giving us, when you do pH equals pKa plus the log of conjugate base over acid, that's where pH equals pKa comes from. In this case, we have no measurable conjugate base on the other side. So the pH is just the pH negative log of 0.033. So if we go back to our original graph, the pH is the pKa at half the equivalence volume for weak only. pH equals pKa does nothing. For the strong one, it's meaningless. I mean, it gives us a pH, but it's nothing special or significant. All right, let's work our way over here. The pHs are different at the equivalence point. But if you look at these graphs, the volume of NaOH to get there is the same. And then because we just finished talking about how after the equivalence point it's completely determined by the sodium hydroxide, and you can see from the graph that they're identical, everything after the equivalence point is identical. So I'm going to do 2 points on this curve. Well, 3. I already did 1. And we figured out the pH was 1 point something because the hydronium ion concentration is 0.033. All right, so we start off with H plus, Cl minus, and water. And it's 0.1 molar. So what's 0.1 molar HCl? Negative log of 0.1. This is negative log of 1/10, which is 1. That was easy. Now, the second part is at the equivalence point. So now I have some H plus, some Cl minus, still my water. I added sodium ions, and I added hydroxide ions. And my hydrogen ion and my hydroxide ion are what's going to react. So I take my 40 milliliters, doesn't matter if it's my acid or my base, still the same 40, times 0.1 over 80. Now on an AP test, they're not going to make them the same molarity for you. In the homeworks, I'm not making them the same molarity for you. So you can't get away with just diluting once. You have to do each solution. So we take the hydrogen and the hydroxide and make them react. And we start with 0.05 of each. And we use up 0.05. So now if we look at the list of 5 things that were in our mixture before, we have no H plus left. We still have Cl minus left. We still have H2O left. We still have Na plus left. But we've used up our hydroxide. So now I have a solution. It's 80 milliliters of solution. that has chloride ions in it, do they affect the pH? Yes or no? No. Water, what's the pH of water? 7. And sodium ions, do they affect the pH? So the pH is 7. So for a strong acid, strong base titration, neutralization is neutral. For a weak acid, strong base titration, neutralization is neutral in terms of electrical charge, but not neutral in terms of pH. So tomorrow we're going to practice a bunch of this. You should try practicing it on your own with the homework that's available. And then Monday we're going to do a lab with it. Okay?